Hi guys, this is a quick video on this particular LED driver card CA Create Alls 6109A. This is a really good driver card, and apparently there are some of the Chinese companies which are producing similar cards. The name may be different, but the overall board and the circuitry will be almost more or less the same. The reason I'm putting up this video is that when I got this card for my 55-inch LED TV, I had trouble figuring out how to adjust the output current on this particular card. So I looked on internet, and I wasn't really able to figure out how to manipulate these resistors. But eventually, after going through a hard time, I was able to find out what it is and how to do it. So if any of you guys are in the same dilemma, this video will really help you. So first of all, you need to focus on these resistors. So remember, from the chart or from wherever you have purchased it, they would have advertised it as the card with 250 or 248 default milliamperes of current, and also it is capable of delivering up to 600 milliampere. So these three, this is a no, first of all, look at this one. This is 50 milliampere and this is 100 milliampere, and there's a line dividing in the middle. So anything that's on the right is all these resistors actually add up 100 milliampere, and anything on the left of this dotted line, all these resistors add up 50 milliampere. So how it works is really interesting. Unlike the other versions of these Create Alls circuit boards, this particular driver works in a slightly different way. Not exactly different, totally different, but slightly different. So how it works is that these three boxes, you can say that there are white lines at the bottom. So these white lines indicate that they have been short circuited internally. So there is an internal connection to these three resistors. Similarly, if you see here, there's a white line in top which shows that all of them are internally connected. So all these are not internally connected at the bottom. So 2 here and 4 here, they are not internally connected at the bottom, but on top they are all connected. So this is, as initially mentioned, that this is 100, all these resistors will 800 milliampere. So these two will add 200, and then there's a 51, so 250. So these three resistors are adding 250 milliamp to the output. So if you want 350, all you need to do is join these two resistors here, these two solder points here. So once you put a jumper in it or put a bridge in it, it will add 300. It will, the output of this particular board will be 350. 1, 2, 3, and 350. If you want 450, you can put another jumper here. But if you want, let's say, I don't know, like 300, only 300 milliamp, in that case, these three are already connected. All you need to do is 850 here. So depending upon the current and in the increments of 50 to 100 milliamps, you can actually use this whole configuration to set up a current from anywhere from 50 milliamp to 600 milliamp. Not really sure about the lower limit of the board, but I think it was somewhere from 150, not 50. So you need to check that out, because what's it called? I can't find the right word for it. Anyway, so one last thing. So if all these are internally, if you put jumper between all of them, you'll see that it will add up 100, 2, 3, 4, 400, 450, 500, 550. Hold on. 100, 2, 3, 400, 450, 500, 550, 600, and 650. So apparently it adds up to a maximum of 650 milliamps. but if I remember correctly, it has been rated for safe use for up to 600 milliamps. So yeah, probably not a good idea to collect the last one. One last thing. So as I mentioned earlier, since these are internally connected, so once you are trying to add up, you have to move out from left to right, from middle to right, or middle to left. So you can't really jump to these last two and expect 100 milliamp addition while these two are not connected, so it won't work. So remember, start from the middle, go to the right or go to the left. Thank you for watching.